This tutorial is going to go through how to write the equation of lines based on different combinations of information that you could be given. First, we're going to look at how you write the equation of a line when you're given the slope and the y-intercept, and that's pretty straightforward because you can write it right into slope-intercept form. So if I'm given the slope and the y-intercept, then remember I'm writing it in slope-intercept form, which is y equals mx plus b. And if that is my slope and this is my y-intercept, then all I have to do is substitute those two things in. So it would be y equals my slope times x, so negative 5x, plus my y-intercept, which is 2. Same thing here. My slope times x plus my y-intercept, which is negative 2. So I can either put plus negative 2 or just minus 2. Either way is acceptable. If I have a slope of 0, then when I write it, it would look like this. In this case, any value of x that I plug in for 0 is going to become 0, and 0 plus 3 is always just 3. So this ends up being the line y equals 3. If I have a slope but I don't have a y-intercept, then it's going to look like this, where I have a y-intercept of 0, and it's just going to end up like that. So just be careful where you're plugging in the 0 and make sure it's the appropriate spot. If I'm going to write the equation of a line and I'm given the graph, the first thing I want to do is I want to use my slope-intercept form, y equals mx plus b, and find two good points on the graph, and I'll talk in a minute about what I mean about good points. Using those 2 points, I'm going to find the slope, and remember my formula for slope is the change in y divided by the change in x. I'm going to find the y-intercept from the graph, and then I'm going to put my slope and my y-intercept in just like I did on the previous problems. So here, notice I've highlighted 2 good points. What I mean by that is they cross right in the corner rather than slightly above or below. So this one crosses right in the corner, as does this one. So this coordinate right here would be 5, 6. And this coordinate right here would be 0, 2. Now I could plug these in to find my slope. So I'm going to do that, and then I'll show you another way to do it as well. Remember, I'm using y2 minus y1 over x2 minus x1. So I end up with 6 minus 2 is 4 over 5, so my slope is 4/5. Or I could just count from this point up to this point, and I go up 1, 2, 3, 4, and over 1, 2, 3, 4, 5, and that gives me a slope of 4/5. So I end up with a slope of 4/5, and again it should be positive because this line has a positive slope, plus my y-intercept, which I can see from the graph is positive 2. Again, I've highlighted 2 good points here. The coordinates are 3, 0 and 0, negative 2. Sorry. Come on. Try that again. 0, negative 2. But instead of plugging that into the slope formula, I'm just going to count. My slope is up 1, 2, 3. Nope, just kidding. Up 1, 2, and over 1, 2, 3. So my slope was up 2 over 3, rise over run. So I have y equals 2/3 x, and then my y-intercept is negative 2, so minus 2. If I count for my slope, my rise is up 1, 2, 3, and my run is -1. So remember that can be written as 3 over -1 or -3 over 1. And actually each of those simplifies to just be -3. So it's probably easier to just write it that way. So I get -3x, and my y-intercept is 2, positive 2. My slope here is 2 over 1, which simplifies just to be 2. And my y-intercept is 0. So I end up with y equals 2x, and then again, I could put plus 0, but I don't need to, so this would just be my answer right there. For this one, whether or not you have memorized what the slope of a horizontal line is, you could just do rise over run. My rise is 0, and my run is 1. 0 over anything is just 0, so I have a 0 slope, which, remember, looks like that, and my y-intercept is 3. Okay? Now, you could also just have memorized that the equation of a horizontal line is y equals a number, and my y value all along this line is 3, positive 3, no matter where I go. Same idea here. If y equals a number is my horizontal line, then x equals a number is my vertical. Or you could look at it as far as my slope, or excuse me, writing it in slope-intercept form. So my rise, let's just pick 2 points. If I pick right here and right here, my rise is 1, but my run is 0 for my slope. Well, anything over 0 is undefined. So that means I don't have a slope. But I also, again, am looking at my x value is -6, and no matter where I am on this line, my x value is always -6. My slope for this one is up 2 over 1, and my y-intercept is -3. For this one, my slope is, let's see, up 1, 2, 3 over -2. So 3 over -2. Remember, the negative could be on top. And then my y-intercept is positive 3. Now, what if I'm given 2 points, and all I'm given is the coordinates? If that's the case, I'm going to need to use the slope formula because I can't count between them unless you graph them, plot them, and then count between them. And then I'm going to substitute one of the points and the slope that I just found into y equals mx plus b, solving for b, and then write my equation. So let's do a couple of examples, and I think that'll help. So I'm given these 2 points. I could plot them and go ahead and find the slope. But if I don't have a graph handy, it may be easier to just plug them into the slope formula. And that ends up being 2 over 2, which is 1. So my slope is 1. So I plug that slope in. Notice that's where this came from. And then I'm going to pick one of the points. It really doesn't matter either way. If one of them has a 0 in it, that's easier, but neither of these do, so I'm just going to pick the first one. And I'm going to plug these values in for x and y. When I do that, you'll see that I'm left with only one variable to solve for, which is b. Once I solve for b, now I have a b and I have a slope that I found up here. So I'm going to write my equation, y equals mx plus b. Remember that this coefficient of 1 isn't really necessary, but I'm just going to go ahead and leave it. Alright, so same idea. Plugging these values in to find the slope. -15 minus 3 is 12. -4 minus 2 is -6. and I end up with a slope of -2. So I end up so far with this. And now I'm going to plug in one of the points. I'm going to pick this one because they're smaller numbers. And I'm going to plug in my x and my y for this. So again, this 2 and this 3 are coming right from here, my x and my y. Multiplying and then adding. So I get 7. So I'm plugging in the slope that I found, which was -2, and the b, or the y-intercept, that I found, which was 7. So there is my final equation. Alright, I'm going to continue going through these next couple of examples, but you may want to pause it and try the next couple ones on your own. So that slope simplifies to be -1. And now I'm going to pick one of the points. Remember, if it has 0 in it, that's typically the easier one, but you certainly don't have to pick that one. So this ends up being 0, so b is 4. So y equals mx plus b. So my slope is -1. And now I'm going to pick a point. It really doesn't matter which one. So I have a slope and a y-intercept, and I'm going to plug those in to my y equals mx plus b. Alright, last example, given 2 points. Finding my slope, remember y2 minus y1 over x2 minus x1. So my slope is -3. And again, it doesn't matter which point you pick, plugging in 5 for y and 4 for x. Adding 12 to both sides, I get 17 for a y-intercept. And I end up with this as my final equation. Alright, how I would write an equation if I'm given the slope and a point. Again, I can use y equals mx plus b. Basically, I just skip the first step of solving for the slope like I did here, and I do the remainder of this same process. So I'm given the slope, and then I just plug in the point that I'm given. So I'm given the slope, and I'm not given a choice as to which point to use. I just plug it in. So it's actually much faster than the previous problems. But I'm plugging in 3 for y and 2 for x, and then solving for b. So I end up with this. So plugging in, -3 for y and 4 for x. Half of 4 is 2. Subtract 2 and I get -5. So my slope intercept form would be 1/2 x minus 5. I'm going to go ahead and plug in my x and my y right away. So this is y equals mx plus b. I was given x, y, and m, so that's where these three numbers come from. So I have y equals negative 2x minus 7. Whoops. Same as before. Oops, sorry. So this is y equals mx plus b. And I'm solving. When I subtract, I get a y-intercept of 0. So this is going to look like that. But remember, that can just simplify out to be this. I'm going to plug in negative 2 for y. My slope is a half, and negative 1 for x. Sorry. Plus b. Add a half. Negative 2 and positive 1/2 is going to be positive 1.5. So I get 1/2 x plus 1.5. If you want to do 1.5 or you want to do 3/2, that's all fine. My my y value is 3. My slope is 2. My x value is 0. So b is 3. Formula, or excuse me, equation of the line, y equals 2x plus 3. You may also be able to just look at this and say, oh, there's my slope, and 0, 3 would be my y-intercept. So could have done it that way as well. This would not be my y-intercept. Be careful, because this is an x-intercept, so you can't do it the same way I was just mentioning on the last one. So I have y equals mx plus b. Subtract, and I have a b value of negative 9. So I end up with 3x minus 9. Lastly, I have an undefined slope. So remember, if I have an undefined slope, that means it's something over 0, some number over 0, which means I rise but I don't run. So that has to be a vertical line. And it's a vertical line that goes through the point 3, 6, which means it's a vertical line that goes through this point right here, which would be the equation, the equation of that line would be x equals 3. Anywhere on this line, my x value is 3, no matter how far up and down I go. So hopefully after this tutorial, you will have a little bit more comfort and confidence in writing the equation of a line based on the information that you're given.